Good morning to everybody. Today we will do the class subject engineering mechanics. Last class I have done some problems and theory of principle of conservation of linear momentum. Today I will also do some problems regarding this theory. Now this is question 121, right? The question is direct central impact occurs between a 300 Newton body moving to right with a velocity of 6 meter per second and a 150 Newton body moving to left with a velocity of 10 meter per second. Find the velocity of each body after impact. Take E is equal to coefficient of restriction E is equal to 0.8. Now I will draw the figure, then explain what is this question, then I will do the problem, solve the problem. Clear? This is before impact, this is after impact, right? This is body 1, body 2, this is body 1, body 2. Clear? Now 1, 2, 1, 2. This is before impact. This is after impact. Clear? The question is direct central impact occurs between a 300 Newton body moving to right with a velocity of 6 meter per second. This means U1. This is U1. And a 150 Newton body moving to left with a velocity of 10 meter per second. This is U2. Clear? So this W1 is equal to 300 Newton body, W2 is equal to 150 Newton body. U1 is equal to 6 meter per second towards right, so positive. U2 is equal to towards left, so negative, 10 meter per second, so minus 10 meter per second, right? U1, U2, W1, W2. Now central impact occurs, direct impact occurs between two bodies. So after impact, both the body will move either in the same direction or opposite direction. We will find out what the velocity v1 and v2. Take E is equal to 0.8. E means coefficient of restitution. E means coefficient of restitution is equal to 0.8. In theory, we have discussed it. In theory, when we are derived the formula, we are assuming both the bodies moving in the same direction. So, in that case, m1 plus u1, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. In both before impact, after impact, we are assuming both the bodies are moving in the same direction. So both u1, u2 and both v1, v2 are positive. But here, body 2 moving in opposite direction. So we will take u2 negative. Clear? This is u2. opposite towards left, but we are assuming both the body is moving towards right. Clear? Now, according to, let V1 V2 is equal to, let V1 and V2 is equal to velocity of two bodies after impact. Clear? Now, according to law of conservation of linear momentum, what is the law? M1 U1 plus M1 M2 U2 is equal to M1 V1 plus M2 V2. Clear? This is law of conservation of linear momentum. Here we put W. In terms of W, W1 by G U1 plus W2 by G U2, W1 by G B1, W2 by G B2. Clear? So, both sides G cancel out. This is W1 U1 plus W2 U2 is equal to W1 V1 plus W2 V2. Equation 1. Right? Put in the values in equation 1. Put the values in equation 1. What W1? 300 into U1 6 plus W2 150 into U2 minus 10. Clear? W1 V1 300 into, what is V1? We find out V1 for W2 V2 150 into V2. So 150 to 152. Clear? So 2 into 6 12 minus 10 is equal to 2 V1 plus V2. This implies 2 V1 plus V2 is equal to 2. Equation 1 2. This equation 1, this equation 2. 2 V1 plus V2 is equal to 2. Now, again E is equal to, also E, what is E is equal to? Coefficient of restitution. What E is equal to? Vs by Va. E is equal to Bs by Va. Velocity separation after impact by velocity of approach before impact. That is, what is Bs? B2 minus B1 by B1 minus B2. Velocity of separation after impact by velocity of approach before impact. That is 0.8 is equal to B2 minus B1. B2 minus B1 by U1 minus U2. What is U1? 6 minus 10. So 0.8 is equal to B2 minus B1 by 16. So B2 minus B1 by is equal to 16 to 0.8. 12.6 equation 3. Clear? So B2 minus B1 is equal to 12.6. 12.8 equation 2. This equation 3, this equation 2. So solve equation 2 and 3. So 2 and 3 will solve 2 and 3. Now 2 minus 3. Equation 2 minus 3. 2. 2 B1 plus B2 minus B2 plus B1 is equal to 2 minus 12.8. So B2 B2 cancel out. So 3 B1 is equal to minus 10.8. Clear? What is B1 is equal to? Minus 10.8 by 3 minus 10.8 by 3 is equal to 3.9, 3.6 minus 3.6 meter per second. So this is B1. Put in value of B1 in equation 3. Now from equation 3, B2 minus B1 is equal to 12.8. Clear? What is B2 is equal to? 12.8 for B1. 12.8 plus minus 3.6. So B2 is equal to 12.8 minus 3.6. 9.3. 9.2. B2 is equal to. Clear? Now B1 is equal to minus 3.6 meter per second. B2 is equal to 9.2 meter per second. Right? Next question number 22. 122. Question 122. Now This is question number 122. 122. The question is two bodies, one 8 Newton body and another is 10 Newton body. So, a 8 Newton body moving to right with a velocity of 3 meter per second strikes a 10 Newton body moving to left, right, left at a speed of 10 meter per second. The final velocity of 10 Newton body is 4 meter per second to the right. Find the coefficient of restitution. Coefficient of restitution. First find out the final velocity of first body, 8 Newton body. Then I will find out what is E. E means coefficient of restitution. Now first draw the figure. One, two, one, two. Double one, double two, double one, double two. This is before strike, before impact. Clear? This after impact. After impact. Right? Now, U1, U2, V1, V2. 8 Newton body, double on 8 Newton. Double on is equal to 8 Newton. Right? Double on double 2, double on double 2. 1 2, 1 2. Before impact, after impact. U1, U2, V1, V2. Now, first come to question. The question is 8 Newton body moving to right means U1 this side with a velocity of 3 meter per second. U1 is equal to 3 meter per second and W1 is equal to 8 Newton. Next, strikes a 10 Newton body moving to left with a velocity of 10 meter per second. This is toward the left. What W2 is equal to? 10 Newton. What U2 is equal to? 10 meter per second. U2 minus 10 meter per second. Negative sign means the body moving towards left. Negative means the body towards left. But we are assuming all bodies are moving towards right. So our formula is according to both bodies towards right. So when we are taking left hand, that should be negative. Clear? Now, that is moving to the left, speed of 10 per second. Clear? 8 Newton body moving to right at a speed of 3 meter per second, strikes a 10 Newton body moving to the left at the speed of 10 meter per second. Clear? The 10 Newton body, the velocity of final velocity of 10 Newton body is 4 meter per second to the right. This is V2 to the right. What V2 is equal to 4 meter per second. Clear? Find the final velocity of 8 Newton body means V1 and find the coefficient of restitution E. Clear? Let V1 is equal to final velocity of 80 Newton body. Then E is equal to coefficient of restitution. Right? Now according to principle of conservation of momentum, W1 U1 plus or M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Right? What is M1? W1 में G into U1. What is M2? W G into U2 is equal to W1 G V1 plus W G V2. Right? Now G cancels both sides. G cancels both sides. This is W1 U1 plus W2 U2 is equal to W1 V1 W2 V2. There. Put all the values. Find V1. Now, for W1 80 Newton. Clear? 80 Newton. U1 3 meter per second plus W2 10 Newton into U2. What is U2? Minus 10 meter per second is equal to W1 V1 80. What is V1? We find out W2 10. What is V2? 4. Clear? Now all zeros cancel out. So 24 minus 10 is equal to 80 V1 plus 4. So 14 minus 4 is equal to 8 V1. So 10 is equal to 8 V1. But V1 is equal to 1 by 10 meter per second. This is V1. 1.10 meter per 1 by 10 meter per second. V1 is equal to. Now, clear. 3, U1 3. Yes. U2 minus 10. You will find out V2 4. Clear. Double to 10, double on 80. Correct. 1 by 10 meter per second. Next we will find out E. Now E is equal to coefficient of distribution. What E is equal to? Velocity of separation and velocity approach. ds by va. That is velocity of separation after impact by velocity of approach before impact. Clear? That is E is equal to V2 minus V1 by Q1 minus V2. Right? You put all the values U1, U2, double and double 2 and find the answer. Right? This is question number 22. Now I will do question number 123. Now I will do question number 123. You will find this answer using calculator. As I am not using calculator, so the answer should be slightly different. Clear? I am doing all the problems without a calculator. You use calculator and find the correct answer. This is question number 123. The question is, a sphere of weight 10 Newton moving to the right at a speed of 3 meter per second, with another sphere of weight 50 Newton moving at a 0.6 meter per second. Find the loss of Ke during the impact. Ke is equal to 0.75. Now This is before impact, this after impact, body 1, body 2, body 1, body 2, right? So this is before impact, this after impact. So U1, U2, V1, V2, double 1, double 2. Clear? Now come to question. The question is, a sphere of weight 10 Newton moving to right with a velocity of 3 meter per second means U1 right side. For double 1 10 Newton, U1 is equal to 3 meter per second. Positive. Towards right means positive, towards left means negative. With another block sphere of weight 50 Newton, double 2 50 Newton, moving at 0.6 meter per second, same direction, U2, 0.6 meter per second. Find the loss of K during impact. K E is equal to 0.75. First find out what is V1, what is V2. First find out. Clear? Also given E, what E is equal to 0.75. So first using this given data, we will find out what is V1 and V2, then loss of K during impact. Right? Now, U1, U2, both same direction. First find out what is V1 and V2. According to principle of conservation of linear momentum, clear? Double and U1 plus double to U2 is equal to double and V1 plus double to V2. Right? Now, for double and 10 into U1 3, double 2 50 into U2 0.6, double and V1 10 V1 double 2 50 V2. So 0 0 cancel out, right? Now 3 plus 3 is equal to V1 plus 5 V2. So V1 plus 5 V2 is equal to 6. Question 1. Right? equation 2. Clear? This equation 1. Let's find equation 2. Equation 2 can find out by using the formula for E. E means coefficient of restitution. E. Now, E is equal to, what is E? E is equal to coefficient of restitution. So what is E is equal to? V2 minus U1 by U1 minus. So 0.75 is equal to V2 minus V1. V2 minus U1 by U1 minus U2. 3 minus, what is U2? 0.6. Clear? Now from this equation we find out V2 minus V1 is equal to 0.75 into 2.4. Clear? 0.75 into 2.4. This may be 1.8. 1.8. Equation 2. Clear? Now, my solution from equation 1 and 2. Or calculating equation 1 and 2, we find out B1 is equal to and B2 is equal to. Clear? B1 is equal to minus 0.5 meter per second, minus 0.5 meter per second. B2 is equal to 1.8, 1.3 meter per second. 1.3 meter per second. So you will use calculator to find this value, B1 and B2. Clear? I will write here B1 is equal to minus 0.5 meter per second, B2 is equal to 1.3 meter per second. Right, this is U1 V2, U1 U2. Then we will find out loss of K. Clear? So what is the loss of K? Now, loss of K means initial K minus final K. Because loss means initial must be more than final. Clear? Initial K minus final K is loss of K. Now, loss of kind energy during impact. During impact. So, delta K is equal to total initial K minus total final K. That is total initial K minus total final K. Clear? What is initial K? This K means half m1 u1 square plus half m2 u2 square. Clear? Initial K. Final K half m1 v1 square plus half m2 v2 square. Right? Initial K, final K. Put m into u double by g. What is m1? Double n by g. What is m2? Double 2 by g. Right? So delta K is equal to half double n by g or 1 by 2g into 1 by 2g into m1 u1 square plus m2 u2 square minus double 1 u1 square plus double 2 u2 square. Clear? Minus this is double 1 v1 square plus double 2 v2 square. Put all the values. So delta K is equal to 1 by 2 into g means 9.81. Double 1 u1 square. What double 1? 10 into 3 square double 2 50 into 0.6 square minus double v1 square 10 into minus 0.5 square plus double 2 50 into 1.3 square. Right? So this and this, you get the answer 107 kilojoule. 107 joule or 1.07 joule. So after solving, you will get this is 107 joule. You calculate the answer. Clear? You may calculation, it may be some different. You may calculation find the answer. Delta K. Initial K minus final K. This is change of K. Clear? This is question number 123. Now, this is question number 124, right? The question is, I have already told you what is the recoil of gun. This question is the recoil of gun problem. The question is, a gun weighing 300 Newton fires a 5 Newton projectile with a velocity of 300 meter per second. Gun fires. The gun fires a 5 Newton projectile with a velocity of 300 meter per second. With what velocity will the gun recoil backwards? Clear? When the projectile moves forward, the gun will recoil backward. What is that velocity? If the recoil is overcome by an average force of 600 Newton, we are giving force to the opposite direction of the recoil of the gun. To stop the gun, we will give force. That force is 600 Newton. How far it can the gun will recoil travel? What distance the gun will travel? And how long it can take? Time taken and distance travel. Both are easy asking. Clear? First find out the velocity of recoil of gun, then the distance travel, then the time taken to travel this distance. Now, for gun or projectile, right? For gun, a gun weighting 300 Newton mass, 300 Newton. Clear? The gun it is at rest, so U is 0. Initial velocity 0. Initially, the gun is at rest, so velocity is 0. A gun moving with fires a projectile. Clear? The gun fires a projectile. The projectile is also at rest. Its weight is 5 Newton, small m. Mass of projectile is equal to 5 Newton. It is also rest, so small u 0. Clear? For gun, capital U 0, initial velocity 0. For projectile also, initial velocity 0. Now, after firing, the projectile will move forward, the gun will recoil backwards. So the velocity of projectile is small v is equal to 300 meter per second. The recoil of gun, capital V, what is the velocity of recoil of gun? We find out velocity of recoil of gun. Clear? Next question. If recoil is overcome, then average force of the gun will recoil backward, bullet will move forward, will give some force to stop the gun. That force is 600 Newton. Then the gun stops. So what that distance move after firing? Yes. Clear? What time taken? T. What distance travel due to recoil of the gun? What time taken to travel the distance? Clear? Now, according to law of conservation of momentum. Clear? Momentum, initial amount is firing. Momentum before firing is equal to momentum before firing is equal to momentum after firing. Clear? So what is momentum before firing? So M into U plus capital M into capital U is equal to before firing. So M into V plus capital M into capital V. This is 0, this is 0. Right? So what is the MV is equal to? Small m plus capital M 0. What is capital V is equal to? Minus small m by m. Clear? This is equal to small m minus 5 into B, 300 by M, 300. Clear? So B is equal to minus 5 meter per second. Clear? What is B is equal to? What is B? Velocity of recoil of gun. As the velocity recoils, as the gun recoils backwards, so the velocity is negative. Right? Where B is equal to velocity of recoil of gun. Clear? The negative sign indicates the gun recoils backwards. The gun recoils backwards. Right? Now, distance moved by the gun. S is equal to distance moved by the recoil of a gun. By the recoil of gun. Clear? This is equal to S. What is force? What force? Minus 600 Newton. What is F is equal to? 600 Newton. Now, the gun will start with velocity 5 meter per second. So after applying force, the gun comes to stop. Clear? Initially, the gun recoils backwards. It is velocity 5 meter per second. So after applying force 500 Newton, 600 Newton, the gun comes to stop. That means the final velocity is 0. Clear? So according to work energy principle or work energy equation, clear? The work done is equal to change of K. What is the equation? Work done is equal to change of K. So minus F into S is equal to half M into V square minus U square. What is V square? Or V1 square minus U1 square. Suppose V1, we will take V1. What is V1? This minus V. Here, M is equal to WAG, half M for gun, recoil of gun. Means M is equal to WAG, M given. Clear? Here V1 is equal to 5 meter per second, U1 is equal to 0. U1 is equal to 0. That V1 is 0. V1 is 0. Here initially U1. U1 is equal to 5 meter per second. V1 is 0. Put the values here. Now, right, that means average force 600 Newton. So minus 600 into S is equal to half into M per jam 300 into V1 square 0. Initial and final. 0 square minus V1 square I square. Clear? This yes. So this 150. So minus 600 S is equal to 150 into minus 25. Clear? What is S is equal to 25 F4 6.4 meter. 6.4 meter. Clear? This is Newton, sorry. This is Newton. So I will give this is to G by G. Clear? Put G to 10 or 9.81. Clear? So this is Newton, weight. So minus 600 into S is equal to half into 300 into by 10. G means put 10, 0 10 into 0 minus 25. Clear? So minus 40 S is equal to minus 25. What is S is equal to 25 40. Clear? (2.5/4) 6.4 by 10 0.64. This is 0.64 meter. Clear? Now, how long it can take? Time taken. Clear? This is for distance travel during recoil of gun. I'll find out what time taken during this recoil. Time taken T according to impulse momentum equation. Clear? Equation. Now minus F into T is equal to M into V1 minus V1. Clear? Here I have taken V1 U1. So minus F, what is F is equal to 600 into T is equal to minus M double A G 300 by G10 into V1 minus 0. What V1? Here V1 is equal to 0 minus 5. Clear? Minus 5. Now 0 cancel out. 30 20. This is minus 20 into T is equal to minus 5. Right? So minus cancel out. 5 4. So 40 into 1, t is equal to 1 by 4 second, means 0.25 second. Point clear? Clear. This is question 124. Next class I will do question 125. Then I will start circular motion. Next I will do some problems. Clear? I will do some problems and complete 130 number of problems. Next class I will complete 130 number of problems. Then I will start circular motion, which includes projectile motion, circular motion. Hello? We will start curvilinear motion. That includes projectile motion and circular motion. Thank you.